The bending of light when it passes from one substance to another is called refraction. Now, I'm not a science guy, but it says index of refraction equals the velocity of light in air divided by the velocity of light in the substance. You have to use that formula to actually find the answer to the problem. The velocity of light in air is 1.86 times 10 to the 5th power. That's scientific notation, miles per second. The velocity of light through glass is 1.23 times 10 to the 5th miles per second. That's scientific notation. Determine the index of refraction of glass. Give the answer in decimal standard form rounded to 3 digits. Okay, so I use this formula index. I'll just put I equals. Then I see a division operation, and I look up what the velocity of light in the air is. It says it's 1.86 times 10 to the 5th power. If it's in scientific notation, put it in parentheses. Then the velocity of light in the substance, okay, the velocity of light through glass, that's the substance, okay, is 1.23. And I want to change that 5 to a 7, please, 10 to the 7th power, okay, I'm changing the problem, times 10 to the power of 7. Now, I'll give the answer in standard decimal form rounded to 3 digits. So here's what you're going to do. First, you're going to simplify this, okay? It's a division problem, so I kind of make 2 parts. One for the powers of 10, and the other for the actual base numbers. So first, I'm going to take 1.86 divided by 1.23. Okay, and that's 1 point. I know it said 3 digits, okay, but you're going to round that. When you divide that, you're going to round to 4 digits. 1.5121, but then there's a 9 after the 1, so it goes to 22. 1.5122 times 10. Now to figure out what the power is on the 10, you're going to put 10 to the 5th divided by 10 to the 7th. Now when you divide, you take, basically when you divide, you cross out the smaller one, the smaller power of 10, and then you subtract it where the larger one is. That's how that works. So 7 minus 5 is 2. But since the 10 is on the bottom of the division, it's to the negative 2nd power. Now, here's the question, okay, after you simplify, you have to ask yourself, do I have to give the answer in scientific notation or in decimal standard form? Okay, you need to give it in decimal standard form. So instead of worrying about where the decimal's at, in decimal standard form, you just plug that into the calculator. So 1.5122 times 10. To the power of negative 2. Okay, so that's my answer. It says it wants it rounded to 3 digits, so 1, 2, 3. So that's a 5. The next digit's a 1, so that'll stay a 5. So it's 0.015. Okay, and there's your index. So again, you'll plug the scientific numbers into the formula, and then you'll simplify, which is what I'm doing over here. Dividing, but how you divide powers of 10 is different than how you divide just the base numbers there. Okay, now the next one. That's your thought process throughout this. A formula in electricity for determining power when current and resistance are known is P equals I to the 2nd power times R. P is the power in watts, I is the current in amperes, and R is the resistance in ohms. Determine the power in watts, so I'm finding what P equals. When I equals 3.80 times 10 to the negative 5th power, and R, get that A out of there, and R equals 2.90 times 10 to the 5th power ohms. Give the answer in scientific notation rounded to 2 digits. So first you have to replace the variables, okay? So I to the second, I is a scientific number, so what you're going to do with the I to the second is you're going to write 3.80 times 10 to the power of negative 5, but then you're going to write multiplication, and then you're going to write it twice because the I is to the second power. Okay, and then times R. R is not to the second power, so we just write that scientific number out once. Okay, now I simplify. But this time there's no division, it's a multiplication problem. So I'm going to multiply my base number. So I'm simply going to take 3.80 times 3.80 times 2.90. Okay, and then I'm going to take 10 to the negative fifth times 10 to the negative fifth times 10 to the positive fifth. Okay, so I multiply those, 3.80 times 3.80 times 2.90, 41.876, okay, times 10. Now when you're multiplying, you just add the exponents. Negative 5 plus negative 5 is negative 10, plus 5 is negative 5, so the 10 power is a negative fifth. Now, you go one of two ways depending on how they want the answer. You either give the answer in scientific notation. That means you don't do what we did up here. Scientific notation means you got to make sure the decimal's in the right place. The decimal's here, but there can only be one digit before the decimal, so we need to move it here. So I put a 1 next to the negative fifth power, and since I went to the left, I plus 1. Okay, so I have 4.1876 times 10, okay, to the negative fourth power. Now they want it rounded 2 digits, okay, so I just need the 0.18, okay. So I'm going to make my 18 into a 19 because there's a 7 after it. They just want 2 digits, so that would become 19, and we can drop the 7/6 off there, okay, because they want it rounded 2 digits. So pay attention to how many digits they want after the decimal. Okay, next problem. This one's a treat. The amount of expansions of metal when heated is computed as followed. Expansion is equal to the original length times the linear expansion per unit of length per degree Fahrenheit times the temperature change. Those X's mean times. Calculate the amount of expansion for the metal shown. Give the answers in standard decimal form rounded 3 digits. So I have to find it for aluminum, copper. I'll put CO for copper. And then I put carbon steel. Now I'm going to kind of separate these from each other so you can see what I'm doing and I'm not all over the place. So aluminum. I take the original length, so it's 6.7520, times the linear expansion per unit of length per degree Fahrenheit. Well, there it is. It's in scientific notation, so I'm going to put that in parentheses, 1.244 times 10 to the power of negative 5, times the temperature change. So what I have to do to figure out the temperature change is simply find take the temperature when it's heated, 225, and subtract 68. That's the temperature change. Okay, so 225 minus 68, so the temperature change is 157. And now I simplify it. So remember the simplifying, I first worry about my base numbers. I take 6.7520 times 1.244 times 157, okay? And for the powers of 10, I just have the 10 to the negative fifth, okay? So that'll be fine. So I go 6.7520 times 1.244 times 157. Okay, so I'm going to go 1,318.7196 times 10 to the negative fifth power. Now, how does it want our answer? Okay, wants our answer in standard decimal form. So with standard decimal form, I just punch it. I don't worry about moving the decimal. That's when they want it in scientific form. Okay, standard form means I just plug that, punch that into the calculator. Okay, now how many digits do I have to go out? I have to go out 3 digits. So 1, 2, 3. There's a 1 after it, so we're going to write 0.013. And the label on that is inches. It expands that many inches when it's heated. Okay, now if copper, same idea. Okay, I take the original length, 35.7520 times. Linear expansion is the amount in scientific notation. You don't have to put the zeros, you can just put 9, because it times 10 to the negative sixth, times the temperature change. So to find the temperature change, we have to take 97 minus 35, and that's going to be 62. Okay, so I'm going to do the same thing I did up here. Okay, I'm going to take 35.7520 times 9 times 62. Because multiplication is commutative. Okay, you can multiply it in any order. And then the 10 to the negative 6, just kind of nothing to do with that other than just write it in the answer. 35.7520 times 9 times 62. Okay, so CO equals, and I'll write that whole thing, okay? Remember, I know it says round to 3 digits, but don't do that until you're ready for your final answer. 19949.616 times 10 to the power of negative 6. Now, again, they want it in standard decimal form, so I punch that in. 19949.616 times 10 to the power of negative 6, okay? Okay, so there we are. Now I can round it 3 digits because that is my answer, okay? 0.019, if there's a 9 after it, it'll go to 0.020 inches. Okay, so again, it's basically, I'm going to turn this back. Basically, I plug in what I'm doing, okay? Then I go simplify off to the side with the numbers and the powers of 10, okay? And that's what I end with. Then I got to ask myself, does it want the answer in scientific form? If it does, you got to adjust the decimal if you needed to and add to the exponent. If it doesn't, you just plug it into your calculator. Remember, when you're plugging in, in both scenarios, you got to pay attention to the digits they want it rounded to. So 3 right there. Here I simplified off the side, then I took that, times added the exponents. Now this one they wanted in scientific form, so I had to adjust the decimal so there was only 1 digit by 1 place, so I moved to the left, so I plus 1. Okay. Now, I still am going to round, okay, when it said it rounded 2 digits, rounded 2 digits, so 4.18, but it goes to 4.19. Okay, so that's how that works. It's really kind of a 3-step process, okay? So now you're going to find your carbon steel, that's CS, okay? So I'll go 3.0950 times, and then parentheses 6.330 times 10 to the negative 6 times, then I'm going to take 743 minus 84. That's how you find temperature change. Change of anything, you just subtract the 2 amounts, 659. Okay, so now I'm going to simplify this. Okay, now I'm going to take 3.0950 times 6.330 times 659. And then for powers of 10, I just have the 10 to the negative 6 power. Okay, now when I'm writing this step out, I'm just going to go 4 digits after the decimal. Okay, so 12910.6996, that would go to a 7, okay, because there's a 5 after it. If you have the actual 5, you go up. Okay, now again, all these they want it in decimal form, so times 10 to the negative 6, so I'm going to plug that into the calculator. Okay, now remember, instead of writing that whole thing, they want just 3 digits after the decimal. So 1, 2, 3, but that 2 goes to a 3 then because there's a 9. So 0.013 inches. Okay. That's your expansions. Okay, example 4. The wavelength of radio waves is calculated by the following formula. The formula is down here. Okay. Calculate the wavelength in kilometers per cycle when V equals 2.5 times 10 to the 7th, N equals 2.24 times 10 to the 5th cycles. Give the answer in decimal standard form rounding to 2 digits. So L equals, first I set up the problem. V is going to be 2.5 times 10 to the 7th power. And N is 2.24 times 10 to the 5th power. Okay, so I go simplify these. Okay, it's division. So again, I take 2.5 divided by 2.24. Again, when you're doing this, go 4 digits out. 1160, and that goes to a 1 because 7's bigger, so 1.161. 1.1161 times 10, and then to simplify the 10th powers on the division, you go 10 to the 7th, 10 to the 5. Again, when you divide, you just delete the smaller one and subtract that amount from the top, and it's to the second. 10 to the second is on top, so it will be to the positive second. Okay, now you got to ask yourself how they want the answer. They want the answer in standard decimal form. Okay, so if they want it that way, then I'm going to just multiply it on the calculator instead of worrying about where the decimal's at. Okay, and it rounded to 2 digits, but there's already 2 digits after the decimal, so I really don't have to do much. 111.61. Okay, last example, example 5. When uranium nucleus is split, energy is released. The change in energy given by the following statement. Change in energy, which is labeled in units of ergs, equals the change in mass in grams times the velocity of light. Determine the change in energy when 250.675 grams of uranium are split into 232.334 grams, and that many grams remain. Velocity of light is 3 times 10 to the 10th power. Give the answer in scientific notation. So change, okay. Change in mass. Now to find the change in mass, I have to be subtracting the 2 mass amounts, okay. So 250.675 minus 232.334. So before I put it in the formula, I need to subtract. 18.341. Okay, so that's your change, and then times the velocity of light. Well, the velocity in light is scientific notation, so times 3 times 10 to the 10th power. Then I go simplify, okay. I want to multiply the 18.341 by the 3. $55.023. Okay, then for powers of 10, I just got the 10 to the 10th, okay, so times 10 to the 10th. Now, how do they want the answer? Standard decimal form where I can just plug that into the calculator, or do I have to give the answer in scientific notation, okay? If they have to give the answer in scientific notation, you need to adjust the decimal. Remember, you can only have one digit after the decimal, so you're going to move it right there. You just moved it one place, and you moved it to the left, okay? So you're going to add 1, and that's to the 11th power. So 5.5023 times 10 to the 11th, and if it doesn't say how many digits have to come after the decimal, you're just going to automatically choose 4, okay, is good.